Today's lesson is on quadrilaterals in the coordinate plane, and what we're going to do is we're going to use our knowledge of distance formula, slope, and midpoint formula to decide whether these to specify them. To classify them most specifically, I should say. So we're going to first decide when we get these four vertices whether we got a parallelogram. If we have a parallelogram, then we want to decide, is it a rectangle, rhombus, square? If it's not a parallelogram, then of course it could be a trapezoid or a kite. So that's what we're going to do. So let's remember our distance formula. Let's just go ahead and write it down here for old time's sake. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Midpoint formula with a capital M. X sub 1 plus x sub 2 over 2. So halfway between the 2 points. And same thing for the y value. Y sub 1 plus y sub 2 over 2. All right, so we'll use those. Hopefully you're already kind of spinning your wheels in your mind thinking, how am I going to use those? And then we're going to use slope too, as I told you. And what we want to remember is that lines that are parallel are going to have the same slope, and lines that are perpendicular will have slopes that are negative reciprocals of one another or opposite reciprocals. Either one of those is correct. And that's really all the information we need to make these classifications. So there's really no new information here. Just need to remember those things. So let's hop in here and look at this quadrilateral. Quadrilateral GHIJ. Is it a parallelogram or is it not a parallelogram? Okay, let me label these vertices first. It's going to make it a lot easier for me. 0 and U. 1, 2, 3, 4. So 0, 4. And I is 1, 2, 3, 4, negative 1. J is 1, negative 2. G is 1, 2, 3, negative 3, 1, 2, 3, positive 3. So negative 3, positive 3. Okay, so how are we going to do this? How are we going to decide whether it's a parallelogram? Well, why don't we just use the definition of parallelogram and see if the slopes of both pairs of opposite sides are the same. Right? Because then we'll know that those opposite sides are parallel. So let's do this. Let's find the slope of GH. And let's see, that's going to be 4 minus 3, which is 1, divided by 0 minus negative 3, which is positive 3. All right, so let's find the opposite side, which is IJ. So the slope of IJ, hope it's a third. Let's see, I got negative 1 plus 2, so that's positive 1. And then I got 4 minus 1, which is 3. Okay, looking good. So I've got one pair of opposite sides, same slope. One pair of opposite sides, parallel. Let's do the other two. The slope of GJ is going to be 3 minus negative 2, which is 5. And negative 3 minus 1, negative 4. All right, and let's do the slope of HI. And that's going to be 4 minus negative 1, which is 5, divided by 0 minus 4, which is negative 4. So yes, indeed, that is a parallelogram because I know that both pairs of opposite sides are parallel. Definition of parallelogram. All right. Let's do another one. Given the vertices below, what is the quadrilateral's most specific classification? As you would imagine, I'm going to try to sketch this thing first. Let's see. So I got 9, negative 4. I got 8, negative 2. I got 2, negative 5. And 3, negative 7. So maybe that'll be about right there. Okay, So I'm going to sketch this in red here. Here's my quadrilateral. Okay, well, it's not a great drawing. It doesn't really look like, it looks more like a trapezoid, I guess, than anything, but I don't know. I don't know. I've got to find out. So why don't we first check to see if it's a parallelogram, just like we did before. So let's find the, oh, let me label these. Let's see, A, so here's A, and B is 8, -2, so there's B. C is 2, -5, and that would make that D. So let's find the slope of AB. And that's going to be -4 plus 2, so -2, and 9 minus 8, that's 1. So the slope is -2. All right, and then we want to find the slope of the opposite side. So that's going to be CD. The slope of CD is -7 plus 5, which is -2. And 3 minus 2, which is 1. So those two sides, that set of opposite sides is parallel. So now let's find the slope of BC. And that's going to be -2 plus 5, so that'll be 3. And 8 minus 2, that'll be 6. And I could simplify this. And of course, if this was my final answer, I would definitely have to simplify it. But I'm just trying to see if they have the same slope. So I'm not going to slow myself down by simplifying all these fractions right now. Okay, the slope of BC. So now I need to do AD, because that's the opposite side. So the slope of AD is -4 plus 7, so that's 3. And 9 minus 3, so that's 6. So yeah, looky there. I do have a parallelogram. Parallelogram. So I got a parallelogram. Okay, but I'm not done. This is not like the previous question that says, is this a parallelogram? This says, what is the quadrilateral's most specific classification? So now that I know that it's a parallelogram, I've got to decide more specifically what it is, if anything. So how are we going to do that? Well, we got all kinds of ways. Once we know that we have a parallelogram, you know, we know certain things about a rhombus. We know all 4 sides are congruent. We know certain things about a square and a rectangle. Oh yeah, all 4 angles are right angles. Another thing about a rectangle is the diagonals are congruent. Well, hey, I've already ruled out square, right? How come I know this is, wait, -2, 1/2? Oh, I take it back. This could be a square, right? How do I know? Because the sides are perpendicular, the consecutive sides are perpendicular, right? Because these are negative reciprocals, -2 and 1/2. So I've got a rectangle or a square. So, let me see. What should I do? I think, so I just need to decide whether it's a square or not, right? It's a rectangle. It's definitely a rectangle. And so what I need to do is find out if if all the sides are congruent. So let's just do that real quick. Let's find, let's just pick, I don't know. Hold on just a second. Oh yeah, I know what I want to do. I want to check the diagonals, right? Let me check the diagonals and see if they're perpendicular. Because if they're perpendicular, then it's a square, right? And then if I found out that it's a square, then I got to check to see if all the sides are congruent, because it might be a rhombus. So let's check the diagonals and find the slope of the diagonals. So let's find the slope of, let's see, BD. The slope of BD. Okay, we got -2 plus 7, so 5. And 8 minus 3 is 5. So the slope of BD is 1. Let's find the slope of AC. Here's the other diagonal, AC. And right, if those are perpendicular, then I've got a square or a rhombus. Okay, so AC, the slope of AC And the reason I pause here sometimes, guys, is because there are so many different ways you can do this. You could have found the length of the diagonals, and that would tell you something. You could find the lengths of all the sides, and that would tell you something. I'm always in search of doing the thing that will get me there the quickest, but I'm not sure if this is it or not. But let's just go ahead and see. The slope of AC, -4 plus 5, so that's 1. And 9 minus 2, that's 7. Okay, so there are the slopes of my diagonals. They're not perpendicular. So what I have just done is ruled out a rhombus and a square, which makes me know now that by the process of elimination, this thing most specifically is a rectangle. All right? So what I think we have next is 2 more of these, identical to this one. No, 3 more. 1, 2, 3. And then we have one that's a little bit different. So what I'm going to do is I'm going to pause here. I'm going to put the answers up for the next 3, and then I'm going to come back in and I'm going to do number 5 with you. So you do the next 3, just like this one, and then check your answers. All right, here we go. Welcome back. Number 2, as we did in the other problem, we want to check to see if it's a parallelogram first. So I found the slopes of the opposite sides, and sure enough, both pairs of opposite sides are parallel, so I know it's a parallelogram. But then I want to see if it's a rectangle or square. Oh, I already know that. How do I already know that? Because the slopes of the adjacent sides are not negative reciprocals, so I know they don't form they're not perpendicular, they don't form right angles, so I can know it can't be a rectangle and therefore can't be a square. So the only thing left for me to do is to check to see if it's a rhombus, and I could do this by finding the lengths of the adjacent sides, or 2 adjacent sides, right? QR, well, that's what I did actually. I found the length of QR, and it was the square root of 13, and I know that QR is congruent to ST because that's one of the theorems that we know about parallelograms, right? That opposite sides are congruent, so I don't have to go and use the distance formula to find the length of ST. So then I wanted to find the adjacent side to QR, which is RS, find the length of it. It turns out to be the square root of 13 also, which I know that means that's QT has the same length as that. So since all 4 sides are congruent, it's a rhombus. Okay, how about the next one? Well, of course, sketching my figures first, and just like all the other times before, I find out it's a parallelogram. And I know it's not a rectangle because the adjacent sides aren't perpendicular. So this time what I'm going to do, instead of finding side lengths, is I'm going to check to see if the diagonals are perpendicular, right? Because if they are, then I know that I've got a rhombus. So I take my diagonals, JL and MK, and if I had made a better drawing, if you look at point M and point K, they have the same X value, right? So when I think about slope, I would have realized, well, and if I just look at those 2 coordinates, I know that this is a vertical line, right? This is a vertical line, and I found this out when I plugged it in for slope right here. This one's vertical, and when I find the slope of the other diagonal, JL, I get a slope of 11.6, so I can see right away that they're not perpendicular. And since they are not perpendicular, I know that the most specific classification is parallelogram. Number 4, same thing. Found out that I have opposite congruent sides, so I know I got a parallelogram. I also can see that these consecutive sides or adjacent sides are perpendicular to each other because their slopes are negative reciprocals of one another, and that's what I saw right here. So that tells me, well, wait, that parallelogram and rectangle, so that's what that told me. Sorry, I'm getting ahead of myself here. So once I've decided that it's a rectangle, it is indeed a rectangle because I know I've got right angles, 4 right angles, then I just need to decide if it's a square or not, right? Because that would be a more specific classification. And what did I decide to do? I decided again to check the slopes of my diagonals. And when I did that, I did find out that the diagonals are perpendicular, so therefore it's a square. How come it's not a rhombus? Oh, it is a rhombus, right? But a square is more specific, so that's what I have to know. Okay, and then number 5, oh, I told you didn't do this one. So what you want to do right here, it says, what's the most precise classification of the quadrilateral formed by connecting the midpoints of the sides of this kite? So take a minute there. You can see that I have used the midpoint formula in my head, which is not always a great idea. First thing I did is I found the midpoints of all 4 sides, and I did that with the midpoint formula, and then I sketched them in. So if you need to pause for a second and do that, then please do, because you want to have a good picture. All right, so now I'm trying to find, okay, so what do we know about this thing? Well, we know that 2 of the sides are horizontal, and we know that 2 of the other 2 opposite sides are vertical. So we know that this thing is a parallelogram because the opposite sides are parallel. It's a parallelogram. And what else is it? It's a rectangle, right? Because the slopes of adjacent sides or consecutive sides are negative reciprocals, right? A vertical and a horizontal, those 2 lines are perpendicular, so it's also a rectangle. So just like before, now we just want to decide if it's a square or not. Well, it sure doesn't look like a square. And let me tell you what we can do here. Since we actually have these midpoints here, what we can do is we can look, when we go from IK, let me switch my color. I don't know. I'll just change it to black. When I go from IK, the midpoint of IK, over to the midpoint of IT, if you look at these 2 numbers, that I'm traveling horizontally, so from -2 to 4, -2 to 4, that's 6 units, right? 6 units long. So these 2 sides are 6. And then if I look from the midpoint of IT, and this time I'm looking at the horizontal distance, right? Horizontal distance. If I go from the midpoint of IT, which is 2, to the midpoint of ET, which is -2, that's just 4 units, right? So those are 4 units long. So 4 and 4. So it's a rectangle and not a square because, of course, the sides would have to be congruent for a square. So rectangle, most specific classification. All right. What do we got next here? Oh, we got some problems that don't have numbers. They just have letters. We hate it when it's like this, but we're going to have to deal with this. Okay, so let's see what we got here. SQRE is a square where SQ, where's SQ? Here's SQ. SQ is 2A. Okay, it's a square, so I know that all these side lengths are 2A, right? This is 2A units long. This is 2A units long. This is 2A units long because it's a square. The axes bisect each side. Okay, that just means that from E, to here is the same distance as it is from there to there. Okay, so axes bisect each side. That means all those are congruent. So what am I trying to, oh, I'm trying to find all the vertices. Okay, so if this whole thing, if ER is 2A and everything equals 2A, then I know that from the y-axis over to R is A units long, right? This would be A units and this would be A units. So the vertex at R, I got to go over A and I got to go down A, right? down A units. If I look at the vertex at Q, I got to go over A and I got to go up A units, right? For S, I got to go to the left A units and up A units. And for vertex E, I have to go to the left A units and down A units. So that's how I'm going to do problems like those. All right, why don't you pause here and do the next one, the rectangle. RECT is a rectangle with height A and length 2B. The y-axis bisects EC and RT. So you try to find these vertices and come back and check. Okay, you see what we did here? So the y-axis bisects the long sides, EC and RT. So since the total length of RT and EC is 2B units, then I know that when I bisect that, each part is B units. So therefore, to get over here to T from the origin, I only have to go B units. That's where that B comes from. And I don't go up and down, so that's how come it's B0. All right, to get to C, I go over B units, and then I go up A units. That's where vertex C comes from. To get to E from the origin, I go over B units, which is left, so negative B, and I go up A units, which is where negative BA comes from. And then finally, to get over here to point R, I just go left B units, and I don't go up or down, so that's how I got negative B0 for that vertex. Okay, one more. Thanks for hanging with me. I know this is long. The diagram below shows a trapezoid with the base centered at the origin. So the base is centered at the origin. That means this is A units, this is A units. Okay, it says, is the trapezoid isosceles? That is a great question, and I'm going to leave you with this. I'm going to let you decide, using algebra and the other things that we've done in this lesson today, to decide if this trapezoid is isosceles. And I better see something written down on every single one's paper when I check your homework. So this one is for you to do. It's a good challenge problem. Can't wait to see how you come out with it.